In this lesson, we are looking at how to perform composition of linear function. This objective here to verify inverse of a linear function inverse by composition is how we are going to apply what we are going to do today. So a composite function is a result of composing or combining two mathematical functions together so that the output of the first one becomes the second. And this is the notation that you're going to see. And we read all of it, the three versions, we read them as f of g of x. And here we have the steps that we are going to follow when we do the examples. So follow along with me. So if I'm given f of x, which is 2x minus 4, and g of x, which is minus 4x plus 3, find f of g of x. So I'm going to take the f function, and the f function is 2, and then I need, instead of x, I'm going to use g of x. So this is going to be minus 4x, negative 4x plus 3. And then I just continue with the f function, minus 4. So I just simplify that. Get minus 8x plus 6 minus 4. So we get minus 8x plus 2 is the answer. So that's the answer right there. Now we do the next one, g of f of x. So I take the g function, so which is equals to negative. Instead of x, I put f of x. So negative 4, and then I put f of x, 2x minus 4, and then I just continue with the other function. So this becomes negative 8x plus 16 plus 3. So I get g of f of x is equals to minus 8x plus 19. That's the answer right there. Let's do another example. So f of g of x, so I start with the f function, so 3, and instead of x, I'm going to plug in g of x, and I like plus 4, this is equals to 6x minus 21 plus 4, so I get 6x minus 17, so f of g of x is equals to that. Then the next one I do g of f of x, so I take the g function, so this is going to be 2. Instead of x, I'm going to use, instead of x, I'm going to plug in f of x. So then I still need minus 7, so I get 6x plus 8 minus 7, so I get 6x plus 1, and this is g of f of x. It's good to keep writing that notation, that way you get familiar with it. Another example, so this one we are doing g of f of 2. See, the inside has changed. We have f of 2. So I'm going to start by doing the inside f of 2. That means I take the f function, and where there is x, I'm going to put 2, and that is going to give me 1. Then, since I know all this is equal to 1, I'm going to do g of 1. So what does that mean? In the g function, where there is x, I'm going to put 1. Where there is x, I'm going to put 1. So I put 1 there, so I get 6. So what does that mean? Let me just summarize it here. And let me use a different color here. So that means g of f of 2 is equals to 6. That's my answer there. Now we do f of g of 3. I start by doing g of 3, and I take the g function and I'm going to plug in 3 wherever there is x, so I get 8. Then I just need to do f of 8 because all this is 8. So I get, so what do I get? I take the f function, 2 minus 3. So wherever there is 3, there is x, I'm going to put 8. So I get 16 minus 3, which is equals to 13. And that's the answer right there.